Hello, good afternoon, everyone. So I'm Jose Luis Hernandez from Cardiff, and I would like to apologize for not being there, but a personal issue has happened during the last days, and I couldn't attend the conference, so it's a pity for me not being there. But anyway, you can contact me wherever you want, and you will see my mail afterwards. So you can contact me, and we can exchange some question answers after the conference. So my presentation will be mostly about positive energy districts and about the impact monitoring that we should apply in this kind of special definition of districts and a common methodology to be followed in this new concept that arose in the European Commission some years ago. So the problem formulation here is that there is a lack of consensus in the definition of the concept of a positive energy district. So there is no common definition, for instance, considering electrical vehicle, considering charging stations, considering district heating systems. So there are different systems that still there are no consensus about which elements should be considered within a positive energy district. And secondly, is about the absence of standard key performance indicators, even though we have some indicators to evaluate the performance of these districts. Still, as we have a lack of consensus in the definition, we have an absence of these standard KPIs to define or to assess these different districts. Moreover, for calculating this KPI is according to the different definitions that we have for a positive energy district, we should consider that we need a standardized and real-time monitoring systems in order to gather all the information to evaluate the performance, but not only in terms of energy. We should also consider the environment and the socioeconomic aspects. Of course, there is a lack of data harmonization because we have different assets with different elements, different data sources across these positive energy districts, and we should harmonize everything in a common way to collect the data. In this sense, also having the common methodologies to gather the information or to define this kind of monitoring. And of course, we are talking not just about one positive energy district, we are talking about different energy districts around the world. So this methodology should be scalable and adaptable, and everything should be able to be adjusted to different positive energy districts. So everything should be considered within this aspect. In our work, the positive energy district definition is taken from the European Commission. In this sense, we consider a positive energy district as an energy efficient and energy flexible urban area composed by different buildings that are interconnected and are exchanging not only information but also energy. In total, they will produce a net zero greenhouse gas emissions. This means no gas emissions, but with a surplus of energy, mostly coming from renewable energy, like the excess of PV energy that will be exported to different districts. And of course, we should consider and limit this part with a boundary, a physical geographical boundary. So we cannot consider the whole city to be positive, or well, we can consider it, but when this is the boundary. So the positive energy definition is considered within the boundary that we think that or we consider is our group, let's say. In this sense, let me show you the energy flows that are within this positive energy district. So first of all, starting from the right part about the non-renewable primary energy, that can be gas, can be soil, can be the grid. There are different sources that are entering or being energy that is imported into our district. In the second step, we have the energy delivered, that is not only the fuel energy that is inside the district, but also the energy that is exported from the on-site renewable energy, like for instance, the delivered energy coming from the photovoltaic system. We should consider also the losses here. So basically, the delivered energy is the energy that is entering into the energy generation systems, and this energy is used by these systems like the boiler to generate heat, is used by the cogeneration system in order to generate heat and electricity, PV systems, heat pumps. We have different elements that are considered within the energy use. And last but not least, the energy needs that at the end will be energy used for covering the need of heating, the need for lighting, the need for domestic hot water. This is an example of the different systems that we have in our positive energy district. Of course, it can be more because usually we have district heating, we can have boilers, we can have heat pumps, photovoltaics, solar thermal system. So the combination of different elements is how the system is being composed. In this sense, this is critical in our common methodology in order to define which are our energy flows, which is the flows that are entering into the district, the flows that are going out from the district. This means the surplus of energy, which asset is consuming which fuel energy, which asset is generating heat for which need. So this part is key in the definition of the methodology and later in the monitoring program, in the monitoring aspect. Having said that, we should consider, as I mentioned before, the geographical boundary. In this case, our limits are considered on site. This means that we consider the generation systems that are on site, like for instance the photovoltaics or the heat pumps, the distribution elements, for instance valves, pumps, and these elements that are intermediaries in the energy generation. For instance, let me say a geothermal system that has a main heat pump, but it's composed also for different heat pumps in order to distribute this energy. You can see, well, we are using the same naming of the different energy parts. So we have the energy delivered entering in the generation system, the energy used, the energy that is coming from the generation system to the distribution element. Demand side, that is about the energy needs like heating, cooling, domestic hot water, and so on. There is a relationship between the delivered energy and the energy needs, and this is considered by the performance of the different assets that we have in the chain of the energy. But we could also consider the primary energy, because this is the key aspect in the positive energy district, because the energy, the renewable energy is considered to have a primary energy factor equal to 0. This means that the CO2 emissions will be 0 at the same time. So that's why it's very important to have the balance of a positive energy district in terms of primary energy, not in delivered energy. So this is the schema that is simplifying the previous one and considering the energy system limits in our positive energy district, and this is the part to be considered within the definition of the monitoring programs. In this sense, thanks to this, we have different standardized indicators, like for instance the key one, that is the primary energy district energy balance, that is calculated in terms of primary energy again. We have the demand, that is the needs, energy used, delivered energy. So as you can see, we are following the same naming of all the systems within the process. So having a standard methodologies and a standard naming in order to define the methodology, but not only considering energy, but we have other pillars like mobility, environment, or socioeconomic. So as I mentioned before, at the end, the energy-related greenhouse gas emissions should be 0. So this is another key KPI that should be considered, but also thermal comfort. So how we are improving this thermal comfort of the systems, about socioeconomic, about the investments, energy poverty, everything, and of course mobility. Even though mobility is not part of the balance, but at the end is a very important aspect because mobility is generating electricity demand. So all these aspects should be considered within the KPIs. And thanks to this, we can define standard schemas in order to provide the different ways of having the monitoring system. So this is basically having the energy flows that we have within our system and the boundaries that I presented before. So this means we are combining both the energy flows that you can see here. For instance, from the grid, we have electricity going to covering the needs of electricity of the dwellings. We have also district heating network covering the thermal needs for the domestic hot water and heating of the system. We have boosters to cover the domestic hot water demand. So all these energy flows are the flows that are coming from the previous one and the limits that we presented in the boundary. So the boundary, as I mentioned before, is considering the renewable energy system being generated on site. So this means photovoltaics. In this sense, all the energy that is generated on site by the photovoltaics is exported to the grid, while the grid is providing the energy, the electricity to the building. We have also here a battery. In this case, this is a sample of the city of Amsterdam. We have as well a battery that is used to back up energy in order to be used by the dwellings, of course. And in this sense, we have like a standard schema in order to represent the flows, to represent the different generation systems. So we have two different generation aspects. First of all, the renewable energy system on site, and secondly, the off-site sources, like the electricity grid I mentioned before. And in this case, the district heating and cooling network is part of the off-site sources. Why? Because this district heating that is for the city of Amsterdam. So in our boundary, that is the one of the districts. In this case, composed by 5 blocks, as you can see in the image. So as the district heating is outside our boundary, we should consider this part generated off-site. Then, of course, we need to consider also the exported energy in terms of thermal flows and electricity flows that will be part of the surplus of energy. And a second example can be shown with Bilbao, the city of Bilbao. As you can see, the example is completely different. So this means we are covering, of course, the replicability and adaptability issues that we mentioned at the beginning. In this case, we have 3 different heat pumps. One aerothermal, and the second one is for geothermal heat pumps. Here we have the main pump of the system. So this part is outside of the district, or we consider outside of the district, because this is the way to pump the water, while these heat pumps are inside our district that are being used to reheat this water in order to be provided as thermal energy to the or in this case 3 blocks. In the case of Bilbao, we have also the photovoltaic that is connected directly to the grid, and the electricity uses that we have in the district. In this case, 2 main uses: electrical vehicle and other general uses, like it could be lighting, it could be plugs, or this kind of uses within the building. And what we demonstrate is that this methodology that is combining the energy flows together with the boundaries, we are able to generate a monitoring needs, a monitoring system, or a monitoring program that is replicable and usable, because at the end the KPIs needs to be calculated, and not only in this case for the KPIs, but imagine in the case of using artificial intelligence, using data-driven techniques, and we don't know what we are measuring, where we are measuring, so sometimes we neglect what is the data that we have, and with this methodology we are overpassing and overcoming these challenges. And just to conclude, what we have is at the end is a proposed methodology to have a solid and standardized framework for positive energy districts monitoring, but can be extended to any monitoring system, to any data-driven approach. We're integrating real-time data in order to improve also digital twins and impact evaluation. So we are able to replicate in various urban contexts, and providing information reliable, feasible, and creating models towards the neutrality. So basically, we are having a procedure in order to monitor our assets and our element in the energy field. With this, I conclude my presentation. So thank you very much for your attention. Sorry again for not being there. So in case that you need or you have questions, please don't hesitate to contact me. You have my mail here, and it's a pleasure to be in contact with you. Thank you very much again.